This lesson is going to continue our work on factoring quadratics. In this lesson, we're going to be seeing numbers in front of the x squared. Our essential question is, how do we factor them when there's a number in front of the x squared? To do this, we need to remind ourselves of an old vocab term, the GCF, called the greatest common factor. That is a number that evenly divides into all terms of an expression. In this problem, we have 1, 2, 3 terms. What is the GCF that evenly divides into all these terms? It could be a number, it could be a variable, it could be a combination of both. Since this 36 does not have a variable, we are not going to use a combination of both. We are just going to think about the numbers 3, 3, and 36. I hope you can see that all three of these numbers can be divided by 3. We always write our GCF outside of parentheses as we start to factor, because we are undoing the multiplication. 3x squared divided by 3 ends up with x squared. 3x divided by 3 is just the x. And negative 36 divided by 3 is negative 12. Again, the GCF goes out in front of the parentheses. In this problem, you see the 27 in the front. You might think that maybe the GCF is 27. But 45 is not evenly divided by 27. So sometimes, yes, like the first problem, you very much obviously see the GCF. Other times, you have to think about what is the biggest number that could go into both these numbers. That number is 9. 27 divided by 9 is 3. The x squared stays with the 3. Negative 45 divided by 9 is negative 5. The GCF, just like in the first example, always goes out in front of the parentheses. Because if you were to use this 9 with the parentheses, you would distribute and make 3 times 9, 27, and 5 times 9, 45. As we move further into quadratics in this new unit, we need to get used to the quadratic standard form. The standard form of quadratics is ax squared plus bx plus c. We will start to notice and use the equal 0 later on in our lessons. For right now, we will just be thinking about the numbers in these positions. Each of these letters in a problem, of course, would be a number, and they are called coefficients. You will start to hear me talk about C and A lot more as we move forward. Here's how the GCF is going to help us out. If I'm thinking about our last lesson, would not really be able to do something like this because there's a 2 in front of the x squared. But if we look for a GCF like 2, maybe we'll turn this into something I can factor. Let's use the GCF and pull it out of all three terms. 2x squared divided by the 2 is just x squared. Negative 22x divided by 2 would be negative 11. And 36 divided by 2 is 18. What are the factors of 18? The factors of 18 are 1 and 18, 3 and 6, and 2 and 9. Which one of these is going to get me my 11? That'd be the 2 and 9. How am I going to get an 11? By having them both be negative. So our 2 stays in front. Now we know that one of the factors has a negative 2, and the other factor has a negative 9. So the 2 in front of the x squared is still right here in front of my final answer. To do the next kind of example you're going to see, we need to see what happens when you multiply binomials that don't just have x in the first position, like this 2 and this 3 right here next to the x's. So let's multiply this out to see what happens. 2x times 3x gives me 6x squared. 2x times 4 gives me 8x. Negative 3 times 3x, negative 9x. Negative 3 times 4, negative 12. The 8 and the negative 9 gives me a negative 1x with a negative 12 and a 6x before and after it. What I want you to notice is that we will still be thinking about factors of the C number, but we also need to consider that the number in the middle is made from two numbers that don't necessarily come from the 3 and the 4. Instead, it's the 2 and the 3 that control more the 8 and the 9. And the 8 and the 9 is what makes the term in the middle. When we work backwards, we're going to have to pull this term out into two pieces to help us figure out our answer of two factors. Here's how we're going to do that. As I look at this problem, there is no GCF, so that doesn't help me. The way that I'm going to figure out what created this 11x, what plus what makes the 11x, is to take our A and our C number and multiply them together. In this problem, that's 2 times 12, which gives me 24. I need to be thinking about the factors of 24. Of course, we have 1 and 24. We have 2 and 12. We have 3 and 8. And we have 4 and 6. Which one of these sets, when added or subtracted, gives me the 11? That's going to be the 3 and the 8. By adding both of these as positive, I'm going to get a positive 11 also. Now don't take these numbers and immediately put them inside the parentheses, because remember, we have a 2 up here in front, which means that it's going to affect what goes in the parentheses. Instead, since we know 11x comes from a 3 and 8, let's pull it apart. We still have a 12 at the end of this problem, and we still have a 2x squared at the beginning of this problem. What I would like you to think about now is there are two kind of little mini problems. There's the two terms in the beginning and the two terms at the end. 2x squared plus 3x. There's a GCF here, and this is why it was important to try some problems with the GCF. The GCF for 2x squared and 3x would be just an x. 2x squared divided by an x, or pull out an x, leaves me with the 2 and now just an x. 3x with the x divided or pulled out leaves me with just the 3. On the other side of this problem, we have an 8x and a 12. The GCF for 8 and 12 would be 4. And more specifically, it'd be a positive 4. 8x divided by 4 is 2x. 12 divided by 4 is 3. Notice that we have the same exact 2x plus 3 in both sets of parentheses. This is exactly what we want. If we did not get this, we did something wrong in this whole process. So what are my final answers? Since we have 2x plus 3 and 2x plus 3, we're pulling out a 2x plus 3. Since the 2x plus 3 is being pulled out from both these pieces, that leaves me with an x plus a 4. And that is my other term. The matching set of parentheses is one of our factors, and the GCFs are the other. Remember, one pitfall is to immediately take these two numbers and start putting them into the parentheses. Don't do that. The other pitfall is to forget to do the step of A times C from the very beginning. The third pitfall is to take the 24 and put it right here. So be aware of all those problems. Don't put these straight into parentheses. Don't forget about A times C. And don't put the 24 right here. Let's try that one more time to kind of get a handle of how this works. Remember, our first step is to do A times C. A times C in this problem is 4, and the C is a negative 3. That gives me a negative 12. What are the factors of 12? Well, we have 1 and 12. we have 2 and 6. We have 3 and 4. Which one of these sets, when added or subtracted, is going to help me get this 1, remember this 1, in front of the x? That's going to be the 3 and the 4. I'm going to get that from subtracting. Using a -3 and a +4 is going to give me a +1. So this is the combination I want to use to split up my 1x. So my 1x gets split up into a -3x and also a +4x. After it gets broken apart into these two pieces, there's still a -3 at the end, and there still is a 4x squared at the beginning. Now it's time to kind of break this apart into two problems to think about GCFs. What's the GCF for 4x squared and 3x? I notice they both have x's. 4 and 3 aren't compatible that way, but they both have x's. The GCF is just an x. 4x squared, pull out an x, leaves the 4, and now just an x. -3x, pull out the x, leaves you with just the 3. As I look at the 4x and this -3, I realize that there's no GCF here. But we still need to get some number to come outside of that set of parentheses. We just need to put a number that's not going to change anything, because this 4x minus 3 already matches this set of parentheses. So we still want it here. The number that's going to do that is 1. 4x divided by 1 is still 4x. -3 divided by 1 is still -3. Now I've assured myself that the parentheses match. Our final answer is to write the matching set of parentheses, 4x minus 3, and the other factor comes from the two GCFs I found, x and 1. Now I know that this process can seem complicated and maybe even a little long, but with enough practice, you're going to be able to get it. Believe me, you can. But if you have any questions, please make sure you write them down in your left columns and you bring them into class so that we can work on them and answer them and clarify. Also, don't forget to hit the continue button below the video, answer the quick questions, and hit submit so your note and your video is counted. Okay, I look forward to seeing you guys back in class.